This video is going to go through the statistical distributions assignment for statistics, and I'm going to give some hints and tips for quite a lot of these questions to give you a bit of a head start on some of them before you submit. So starting with question 1. So we've got a discrete random variable x given in function form. So that's with these brackets here in this notation there. So we've got the chance that x is k times x squared minus 9, where x is 4, 5, and 6. And it's 0 otherwise. Okay, and k is a positive constant. And it's probably worth noting that it's positive because there'll be some way of, there might be something that's involved later. Okay, show that k equals 1/50th. So the first thing I would do is, I don't particularly like the function notation because it's difficult to interpret quickly. So what I'm going to do is I'm going to start by trying to get this into a table form. So I've got values of x of 4, 5, and 6, and no others. So I think it's worth starting off a table like this. So here's our headings, and then I can have 4, 5, and 6. And currently I don't know what k is, but I can get all of my probabilities in terms of k by substituting in 4, 5, and 6 into that row of the function there. So if x is 4, I'm going to have k times 4 squared minus 9, which is 7 lots of k. And that's going to go there. And I can do the same for when x is 5, and then the same for when x is 6. And then to show that k is 1/50th, that's going to rely on the fact that for any discrete random variable, the sum of the probabilities has to equal 1. Okay, so it should be clear how to proceed from there. When it wants you to find the probability distribution of x for part B, that's going to involve drawing a table. This is the probability distribution given as a table, but seeing as you know the value of k, you're going to be able to give numerical values for these three here. Okay, so it's finishing off the table and replacing k with the value that we know it is. Okay, and that's 5 marks for question 1. Right, question 2 then, moving on. We've got a larger discrete random variable with more values here. We've got 4 rows given in this bracket this time. And again, I would look at the possible values of x, probably put them into some ascending order because they're all kind of out of order in these rows. And then I would turn that into a table. So let's see what we've got. We've got x values and then their probabilities. And it looks like we've got -2 up to 2 inclusive. Okay, so bear in mind, each value of x takes the corresponding probability on that same row. So you can go through and then write down something underneath these in order to initially fill out the table, and that will help you work out alpha. That's part A. Once you've got alpha, you can then do as we did in question 1 and fill in the rest of the numerical values in this table because we will now know them all. And then you can get these probabilities here. Pay attention to what the inequalities are doing. You've got -1 less than or equal to x less than 2. And then you've got the probability that x is bigger than -2.3. Okay, so you've got to work out which values of x are allowed in that interval there. Okay, only 4 marks for that question there. Question 3. This is the third of the function notation questions. So we've got k times 2 minus x for x equaling 0, 1, or 2. We've got k times x minus 2 when x is 3 and 0 otherwise. And then we're firstly showing that k is 0.25. You can use hints from the previous 2 questions to work that out. But then after that, we take 2 independent observations, x1 and x2, out of x. So we've done a lesson on looking at independent observations here, where we kind of take 2 at a time and do something with those values. So we've got the probability that x1 plus x2 equals 5, and we're showing that that equals 0. So what we're doing is we are taking values of x between 0 and 3. We're taking 2 of them, and then we're trying to get them to add up to 5. So what I would do is I would list combinations here as to what pairs of numbers you can pick for x that would make this total of 5. Okay, and because we've only got 0 to 3, there shouldn't be too many options there. And what's going to happen is by adding up those separate probabilities for those options, you're going to hopefully show that that equals 0, and then you're done. Okay, the complete probability function for x1 and x2 It is asking for a function, so I would write that in this form up here as we've got up there. So I would set it out this way. The probability that x1 plus x2 equals a specific x1 plus x2 equals, and then I would set out some rows here. So see if you can collate all the information down and write down all the possibilities for x1 plus x2. Now once you've done that, you should be able to work out the chance that this total is in between 1.3 and 3.2. Okay, and that's a couple of marks. You have to do a lot of this systematically because it's easy to forget options, or if things are out of order, it's easy to miss them or duplicate them. So just be careful there. Okay, moving on to question 4. So this is going on to the binomial half of the assignment. So these questions are to do with the binomial distribution. We've got Amir and Ed playing each other at badminton, and for each game, independently of all others, the probability that Amir loses is 0.2. Just pay attention to what we're talking about here. We've got the loss chance here is 0.2. So if we're talking about winning at any point, then just be careful about what probability to use there. Find the chance that in 9 games, Amir loses. Okay, so we're being consistent here with the losses. So we're losing exactly 3, and then fewer than half of the games. Okay, so I'll leave it to you to interpret what that means. You want to firstly write some kind of probability statement. But you firstly got to define this x, and you're going to be wanting to write down the parameters of your distribution that you're using there. Okay, it's worth you doing that for each question. Okay, bear in mind you can use your calculators for these as long as you write down these p brackets, and then that should be good to go. All right, question 5. We've got MP3 players sold in batches of 20. Long-term analysis shows that 5% of the players are faulty. And then in a single batch, we want a model for the distribution of the number of faulty MP3 players in a batch. All right, so clearly we know the distribution that's going to be used. You want to state the name of it, and then state the parameters. Okay, you can do that using the notation above, but it's fine just to do this, state the name and the parameters. Okay. Then it's a calculation question. Find the probability that a batch contains no faulty MP3 players, so none at all. It might be worth you writing down the formula that you're using to do that as a bit of practice, because that's an easy option there, so having no faults. And then show that the probability of there being more than 4 faulty MP3 players in a batch is equal to 0.0026 to 2 significant figures. So again, write down what you're calculating, use your calculator, and it should match that to 2 sig fig. Okay, that's question 5 done. Question 6. Right, Emma throws a fair coin 15 times and records the number of times it shows a head. State the distribution again to model the number of times the coin shows a head, giving any relevant parameter values. Okay, so again, name it, state the values of all the parameters. And then we want exactly 8 heads and at least 4. Okay, another bog standard binomial question. It should be pretty easy if you follow the same advice above. Right. 7. A manufacturer produces large quantities of coloured plates. It's known that from previous records that 6% of the production will be blue. So in a sample of 10 plates, okay, again, so distribution to model the number of plates. Right, state why it's suitable. We're going to need to refer to the conditions under which a binomial distribution is appropriate. Okay, so go back through the list. We had about 4 or 5 of these. And then state which ones apply in the context of the question that it's talking about, okay, in the context of the scenario. Okay, so refer to those. And then find the probability that there are more than 2 blue plates in the sample. Okay, another easy question there. Okay, finally, question 8. This one throws you for a bit of a loop here. Write down the conditions under which the binomial distribution may be a suitable model to use in statistical work. So we've covered all of those. I've done a video on it, and you should have it in your class notes. So just list in using sentences, please, the conditions under which you'd use a binomial distribution as to what's happening in your scenario for this to work. Okay, now you've got to read this carefully. A six-sided die is biased, and the die is thrown. The number 5 is twice as likely to appear as any other number. Okay, so from that, you should then be able to work out probabilities on that die, okay, as to what could occur when you roll that once. All the other faces are equally likely to appear. Okay, again, that's going to help you work out some probabilities. The die is rolled repeatedly. Okay, so this should throw some red flags. It's rolled repeatedly, but I'm not telling you how many times it's being rolled. Okay. Find the probability that the first 5 will occur on the 6th row. So you'll notice that this language deviates a little bit from binomial language, and in fact, you're not actually using a binomial distribution. Okay, hopefully that's something that you spotted when you've seen at least this part. Okay, so that's a big clue as to how to tackle this question. There is a name for the actual distribution that's given here, but it's not something that I'm going to go through because it's not in the A-level course. You can look it up if you want to. The first 5 will occur on the 6th row. So think about what could happen, or I should say what has to happen. Okay, and I mean that in terms of what could happen on your particular throw. So what has to happen on the first row, what has to happen on the second throw, and so on up to the 6th throw, in which you've got to get a 5. Okay, and that should give you an idea as to how to work these things out. And then in the first 8 throws, there will be exactly 3 5s. Now we're back to binomial, aren't we? Because this is a fixed number of trials, 8 throws, and we know hopefully the probability of getting a 5, and we want exactly 3. So this is back to binomial again. Okay, so to summarise, for part A, list out the conditions for a binomial. That's in notes. B, part I, I want to see some kind of calculation. Okay, I want to see a sum that you're doing that shows this outcome occurring. Okay, show calculation. And then B, part 2 is back to a standard binomial question. Okay, and I'm pretty sure that's the rest of the questions done. So if you've got any problems with it, feel free to give me an email. I can get back to you on it and give you all the help that you need. And you're submitting this to Show My Homework on Tuesday, please. All right, thanks, Year 12. See you soon.